Okay, cross country and Aubrey and whoever else is missing from this. Simon, maybe, I don't know, Kellen. Okay, a lot of people. This is the second half, part B of 2-5. Homework assignment is 2 through 12, the evens? No, 2 through 12 all. I'm sorry. 1 through 12 all. Blah, blah, blah. 1 through 12 all. You should have 1 through 6 done, yeah? We're going to do the back half today, the second half, which is all the formulas for the three-dimensional figures for volume and surface area. Open the door, would you please?
Are we going to go over all the homework tomorrow?
What?
Are we going to go
I am going to be gone tomorrow. So we're going to turn in 2 homework assignments on Monday. Tomorrow, as a reminder, we are not doing section 2-6. We are doing 2-7. And then Monday, we're coming back to section 2-6. And we'll take Monday, Tuesday to do section 2-6. Because I need to be here to help you through section 2-6, okay? But 2-7 is pretty easy, so I recorded that one also. That one will post in the morning, and you guys can watch it tomorrow, 8th period. Here is 2-5, part B. Here we go. You are going to need to look at this little chart down here, okay? Maybe put a star or something by this chart so you can come back to him. This is where you will find all of the formulas that you need for surface area and for volume, okay? Here is my announcement. On the test for this chapter, which will be coming like probably not next week, but the week after that, you will have, I will give these formulas to you. You will not be expected to memorize them, but you will be expected to memorize perimeter and area of circles, rectangles, squares, triangles. Those 4 objects. You should know those already, right? Perimeter, an area, or circumference if it's a circle, right? Okay. These ones you are not expected to memorize, but here's how these go. Okay. A prism. This is surface area. I don't know why they call it, they used to call it L, but they don't anymore. S or SA, I'll call it SA. Here is the formula for finding the surface area. All right, so the surface area is the area of all the surfaces, right? Area of all the surfaces. So what they've done here is, let me kind of break down this formula for you. 2 capital B. Down here it tells you what capital B stands for. Capital B is the area of the base. Do you see that? So let's say that this dimension right here is 3, this dimension is 2, this dimension is also 2. I don't know, right? If we say the base is the bottom, what's the area of the bottom? 6. And the top is also 6. Therefore, we have 2 times 6, which is 12, right? The top and the bottom. Okay, now, what does capital P stand for? The perimeter of the base. Now, the reason why do they do perimeter of the base is because that gives us like this dimension around here, and then it fills it up by taking it times the height. The perimeter of the base times the height will give us the edges around it, right? Okay, so what's the perimeter of the base? What's capital P in this case?
3.
It's going to be 2.
10, right? 3 and 2 and 3 and 2. That's going to be 10 is capital P. What's H? 2, right? The perimeter of the base. I did 3 and 2 and 3 and 2. That's the perimeter of the base, 10 times 2. So this is 20 plus 12 or 32. And let's say how we did inches is surface area inches, inches squared, inches cubed. Inches, surface area. It's still an area. It is squared. Every unit is squared. Square units. Okay? Volume is cubic units. So it is inches cubed or whatever units cubed, right? Okay? Volume is capital B times H. What was capital B again? The perimeter, or the area of the base, which in this case is 6 times the height, which was, you can't really see it very well, 2. Okay, think of volume as me filling this with water. It is going to fill in the base first. That's that 6 units. And then it is gradually going to fill this container up the side, right? Fill the base first, that's 6 units, right? Fill up the side, that's 2 units. So this would be 12 inches cubed. Now, is it always true that the surface area is bigger than volume? No, in fact, most of the time volume is bigger than surface area, right? If you have an object that is optimizing, which means like making the most bang for your buck, right? You want the least amount of surface area for the most volume. Well, you want it to hold the most amount using the least amount of materials. Does that make sense? Yeah. Okay, so this is kind of backwards. These dimensions are not very good. It's not giving me the most bang for my buck. My volume is smaller than my surface area. All right, let's move on. Surface area of this thing, this is a pyramid. There are two different things that have to do with height. One of them is regular height and one of them is slant height, okay? The regular height, which is labeled as H, this is regular height. It is as though I drive a pole down the center. It is the height inside of a pyramid that you can't see. The slanted height is this height right here. That is out of slant. It's like the edge of the, not the edge, but like the flat surface, right? The height of that flat surface. And that is called L. This is the slant height. Okay? All right, we'll go through and we'll do an example here in just a little bit, but that's surface area volume of that thing. All right, real quick. Perimeter of the base. Real quick. Take a look at the difference between a prism, which is this guy for volume, and the volume of a pyramid. They're the same formula, but one of them is 1/3. If I do capital B times H, this is 1/3 capital B times H. Because if I make the other two pieces, guess what he makes? The full prism, right? Okay, it's 1/3. All right, now I'm going to skip over to cylinder and cone. Check this out. Volume of a cylinder versus volume of a cone. Same thing. It's 1/3 because if I continue this off and make like another cone on this side, another cone on this side, it will make a full cylinder. Make sense? Yeah. So this isn't very hard to figure out what these variables represent on a cylinder. Pi is a number. You will use the pi button. You do not use 3.14 or it will be wrong. It will be not quite rounded correctly. R, what's R stand for? Radius. What's H stand for? Height. There's only two things that are happening in a cylinder, the radius and the height. Sometimes they will give you the diameter instead. You split it in half, right? So if the diameter is, let's say 8, the radius is 4. So be careful. Sometimes they'll give you the diameter instead. Okay, cone is the same way. Now you can see it a little bit easier, which one's the height and which one's the slant height. Height is down the middle. It's like what you can't see, right? It's like driven down the center of the cone. Slant height is the edge. Got it? Slant height is as a cursive L. Okay? A sphere only has a radius as a dimension. So you have 4 pi r squared or 4/3 pi r cubed. Okay? Do you know how to type 4/3 pi r cubed into your calculator? Okay, if you have a dumb calculator, you can go 4 divided by 3 times pi times whatever your r value is cubed. That's how you can literally type it in. 4 divided by 3 times pi times r cubed. Okay? Got it? Go back to pyramid. Okay? What doesn't make sense to you?
There's 4 triangles on the outside. Right?
Are you talking about surface area or volume?
Yeah, surface area.
Okay.
So when you want to find like the area of all 4 of the triangles,
More?
Right.
Isn't that just more effort?
isn't that like basically just finding one side?
Okay. So the area of one of these triangles right here, to find the area of one triangle, I take this base times this height. They're calling that the slant height. This instead of doing each one individually, they're taking all 4 of them at the same time, which is the perimeter of the base times the height. But then I have to do half because it's a triangle, right? Half the base times the height. It's just that this is the base and I'm doing the whole perimeter, meaning I'm doing all 4 of them at the same time. Does that make sense to you? Yes? Yeah, that's where that comes from. I'm glad that you're looking like, I'm glad that this is like sinking into you, that you're like trying to understand where the formula comes from. That's good. All right, let's do an example. This is a what on example 3? This is the cone. Let's talk about things that we need for a cone. We need we need surface area and we need volume. Okay? I know that volume of a cone is 1/3 pi r squared h. The surface area of a cone is, I don't know. Give it to me. Surface area of a cone, pi r L plus pi r squared. Those are the 2 formulas that we need. All right, let's talk about what we have and what we need, all right? What is 8? The height. Regular H or the slant height? L. Regular H. What's 15? The radius is 15. I don't know the slant height L. That's what I don't know. I have to figure it out. How do I figure out what the slant height is? Use the hypotenuse. A squared, B squared, C squared. So 8 squared plus 15 squared equals C squared. If you know your Pythagorean triples, this one comes out nicely. Do you know this one, Jack?
What?
8, 15. 17.
Wow.
64 plus 225 equals C squared. 64 and 225 is 289. And the square root of 289 is 17. So regular slant height is 17. All right, here we go. Let's find surface area. I'm just going to plop stuff in. Pi times R, which is 15, times the slant height, which is 17, plus pi times R is 15 squared. Do you know how to type this in? I would get a calculator out and practice.
I can do it in my head.
You can. Okay, get a calculator out and try practice typing it in.
I got in the thousands.
Yeah.
I got 1508.0
Hold on, let me try.
inches squared.
I got. I don't know what I'm doing. I got 1507.96.
Okay, but 0.96, the 6 is going to round the 9 up
About
to
1508.
1508.0. Yeah. Okay, good? We're going to talk tomorrow on the video about the difference between that and 0.0.
How do you,
What?
Yeah. You can't round it and put
It was 1507.96. So the 6 rounds the 9, that to an 8, and then it's 0.0.
Oh, I know.
That make sense? Yeah.
I thought it was just
No, no. It was 0.96. Okay. All right. Next, 1/3 pi r is 15 squared times the height, and the height is 8. Hold on, I'll answer your question here in a second. Okay. How do you type this in? If you want to save the 1/3, I would take pi times 15 squared times 8, and then you can divide it by 3. Does that make sense? 1/3, it's like dividing by 3. Practice typing that one and see what you get. I didn't get it. Oh, 1885.
no, cheater. Wrong.
Is that right?
Yeah.
1885.0 inches cubed.
Yep.
You put the wrong formula.
All of them or
1885.
just round the 9 up?
Just the ones around the 9 up. Yes, good question. Okay, good. They will say round to the nearest tenth. The nearest tenth is 1 decimal place, yeah? Okay, do we get how this works? The hardest part is figuring out how to type this into your calculator, so I hope you're practicing. Okay, let's go to another shape. Let's go down to, I don't want to do I want to do that one?
No.
Do we want to do the ball here, the New Year's Eve ball?
No.
Yes.
No.
Yes. Yes.
Yeah. The New Year's Eve ball, this is example 4, is a geodesic sphere that is 12 feet in diameter. That's not that big. 12 feet in diameter? That's not that big. Okay? That means the radius is 6 feet. Okay? 6 feet in diameter. Or 6 feet, 12 feet in diameter, 6 feet for the radius. Okay? It weighs this many pounds and is lit by this many LED lights and is covered with this many crystal triangles. Some of that information we don't need. Okay? How many lights are contained on the ball's surface with an area of 4 square feet?
Is this the actual, like,
What?
never mind, that sounds stupid.
Yeah, you do.
Okay, so we're looking at surface area, all right? I want to know surface area of a sphere, which is 4 pi r squared. Is that true? Yes, we know that the radius is 6, right? So 4 times pi times 6 squared. 6 squared is 36. 36 times 4 is 144 pi. Give me the surface area. What do you got?
452.4.
452.4. And that is in feet squared. That is the area of the surface, right? The surface area is 452.4, okay? If you multiply that through, okay? Now, I understand that this is not a perfect sphere, right? Because he's like flat on certain parts, but whatever, it's fine, okay? All right, now, that's not answering the question, though. It says how many lights are contained on the ball's surface area with 4 square feet. I have 452 square feet.
So take
Okay, what would you like to do?
how many LED lights? Divide that by.
Okay, are we looking at lights, LED lights? So this is equivalent to 32,256 LED lights, right? There are 32,256 LED lights on this much surface area. So how do I figure out how many LED lights there are on one of those, on 1 square foot?
32,256.
I'm going to divide that by 452.4 to figure out how many lights are on 1 square foot.
71.
71 lights are on 1 square foot. 0.3, let's go 0.3. 71.3 lights equals 1 foot squared, but I want 4 square feet, so now I take that times 4. So how many lights are on that 4 square foot area?
285.
285.2?
Yeah.
We'll just go 285 lights. Okay, so now at our final step, we'll round, right? 285 lights are in that 4 square foot area. That is not that big of an area, but that is a lot of lights. Okay, do you see how we did all that? Okay, determine the number of lights within 4 square feet. We did all that. Does it ask for another question?
Yeah.
Where is the other question?
Part B, just under it.
Where's part B? Oh, okay, here we go. All right, part B. Shh, look right here where it says part B. Tony is repairing a section of the ball that has a volume of 8 cubic feet. How much does this section weigh? Okay, so now we're talking volume. Volume is 4/3 pi, radius cubed for a sphere, yeah? Okay, what was the radius again? 6. Okay, so take 4/3 pi and 6 cubed is, I don't know. I don't know what 6 cubed is. Type that in for me, would you? 904.8. Check me.
Just 7 million.
216. Oh well, 216 pi.
Did you get 904.8 cubic feet? Did you get 904.8 cubic feet? Okay. And I want to know the weight. So this, in that 904 or 905 almost cubic feet, the weight of it is 11,875 pounds. 11,875 pounds. Okay? So that many cubic feet weighs 11,000, almost 12,000 pounds. So how many pounds is 1 cubic foot? How do I figure that out? Let's divide by 904.8. Okay? So how much is that?
13.2.
13.2?
13.1.
13.1 pounds equals 1 foot cubed. 1 cubic foot is 13.1 pounds. But I want to know the part that he's working on is 8 cubic feet. So now what do we do?
105 pounds.
Take that times 8 and it's 105 pounds?
Yes, because it's 104.99.
Okay, so we'll just round it to the, did they say round to the nearest pound? I don't know, 105 pounds. Okay, do you see how we do that? We reduce it to how many it is per 1 cubic foot, right? Same thing as we did up here. How many lights were in 1 square foot? Okay, got it? Happy with that? Okay. All right, let's do example 5 real quick. Last one. Last one, example 5. Shh. This won't take very long. Last one, example 5. Destiny visits a water park where a new cyclone water ride has opened. On the new ride, a tunnel flows into a large funnel, which is the shape of a cone. The slant height of the funnel is 29 meters. So this is 29. And the surface area is equal to 910 meters squared. At its widest, what is the diameter? Oh, crap. We're working backwards. How do I find the surface area of a cone? By the way.
It's 4/3. No.
Pi RL plus pi R squared, right? Pi RL plus pi R squared. What?
that cylinder?
No, that's
No.
not phenomenal.
This is surface area of a cone.
Cylinder is 2 pi r h plus 2 pi r squared.
Yeah. A cylinder doesn't have a slant height.
Yeah, Brady.
Okay?
Yeah, but like, I thought, yeah.
All right, so this is the formula. Whoop. This is the formula that we have for a cylinder, yeah? Or for a cone, I mean. Okay? I know that the surface area is 910. What else do I know?
I know what
At the widest, it's 29 meters.
At the widest, it's 29. Oh, no. Yeah. The slant height is 29 meters, right? So 29 goes here. Got it?
Okay.
Oh, man. We got to solve for R. How do I solve for R?
You divide by pi, 2 pi. Divide by 2 pi.
No, that's, it's not 29 is the length, 29 is the distance diameter.
No, 29 is the slant height of the funnel is 29 meters.
Oh.
I put that in for slant height. How do I solve this?
Divide by 2 pi. Because there's 2 pi's.
How do I solve for R when R is here and R is here also?
Add.
No.
Wait, no, it's different.
Like I have R squared and R, right?
That's R cubed.
No, that's not R cubed. You can't add those two together. Okay, this one is a really, really, really tough problem. Are you ready?
I thought you said
Okay, I'll show you how to do this. Equals, I'm going to put this in order. I'm going to make this pi R squared plus 29 pi R, right? I'm going to subtract 9/10 so that it's over here at negative 9/10. I'm going to have it set equal to 0. Okay? Does this look like a quadratic function? R squared, R, and number. Okay? Woo! How do I solve it if it's a quadratic function? How about the quadratic formula?
Find the.
Negative b plus minus square root b squared minus, this is all from algebra, all over 2a. You hate this. Okay, what is b?
B is 29.
B is almost 29. B is
Oh,
29 pi. So negative 29 pi. Follow along. Shh. Follow along. Okay, what is b squared going to be? What's 29 pi squared? Somebody take 29 times pi, enter, and then square it.
You get a calculator on the ACT?
Yes.
How good of a.
What is 29 times pi?
8,300.3%.
Yeah.
8,300.337. We'll go 3, 4. Minus 4 times A. What's A?
A is 1 pi.
A is pi. And C is negative 9/10. And what's 29 pi, by the way?
11. This is 4 AC.
Holy schmoly. 4 AC. Okay. 91.1? Okay. This is kind of a mess. Yeah. Okay, so there is that. All right, negative 91.1 plus minus, if I do all of this stuff in here, if I do all of that stuff, that's 4 times, okay. Minus 8300.34. If I do that and I take the square root,
this seems like a lot of work for something you're never gonna do in life.
you just hush.
Hey guys, it's 911. Shut up.
Okay, this is after I take the square root. Let me get rid of this. This is 140.5. All over 2 pi is 6.28. Okay, now what?
Add and divide.
I'm going
so
to
it's
say
an add.
negative 91.1 plus 140.5 divided by 6.28, which is 7.87,
Yeah.
or negative 91.1 minus 140.5 divided by 6.28. I get negative 36.9. What did we solve for? What were we solving for? R. Which one is R?
It's positive.
Can't be negative, right? The radius is 7.87. Is that what they were asking for?
They want the diameter.
They want the diameter, which is
It is gonna
double
be-
that.
Oh, 15 points. It's 15.774.
15.73 if I use the actual value. And that is in feet? Is that in feet or meters?
Meters.
Meters. Perfect. That's the diameter. That was a mess. Hopefully you don't have any like that. Okay? All right, use your time. Listen. Use your time to work on surface area and volume of those guys. Go.
Can I go back in this